Alright, so which statement are correct? Statement 1, which is the volume of a gas at constant pressure increases as the temperature increases. So we need to analyze one of all of these three statements, and we need to assess which of these are correct, right? So now let's first understand what is pressure. What is pressure of a gas? What is temperature of a gas? And what is volume of a gas, right? So if imagine a container like this. This is our container, and we got some gas molecules over there hanging around in the container, and they collide with the wall of the container. All right, it keeps on colliding with the walls of the container, and so this collision is causing the pressure development, right? Because pressure is equals to force per unit area, and when these molecules collide with the wall, they actually apply force on the wall per unit area, and that actually creates the pressure. This causes the development of pressure inside a chamber. So that's what pressure is. The volume of a gas is the volume, the volume, the 3D space consumed by these molecules, right? And similarly, the temperature is the average movement, average kinetic energy of these molecules, gas molecules. The more the kinetic energy, the more will be the temperature, or I should say, the more the temperature, the more the movement of these molecules, right? So if they are moving like heavily in much high speeds, then they must be having high temperature, right? So imagine a good day, a good breezy day, for example. It's 25 degrees Celsius outside, and the air molecules are not very excited, right? They're not rushing around. Why? Because of the kinetic energy they have. That's what the temperature defines. It's the average kinetic energy the molecules has, right? Secondly, if it's really hot outside, then air molecules will be like rushing around each other, moving at very high speeds. So that's what temperature is. Now let's understand which statements are correct. So the volume of a gas at constant pressure. Now here's the key to constant pressure. We're keeping the pressure constant, right? We're keeping the amount of collisions with the wall constant. So the volume of a gas at constant pressure increases. So volume will go up as the temperature increases. So imagine a container, and you need to keep the pressure at constant, right? So you are increasing the temperature, the pressure should also go up, right? If the volume is fixed, right? But we need to keep the pressure constant. So in order to keep the pressure constant, you need to give space to the molecule so that they can adjust themselves so that pressure cannot increase, right? So this statement is right. Why? Because when you keep the pressure constant, the temperature and volume are directly proportional. All right. So you can also use this general formula, the gas equation, which is P equals to Vt, right? And you can compare them. So if you are keeping the pressure as constant, right? If you're keeping the pressure as constant, or actually we should ignore this. So when the pressure of a gas is increased, the particles move closer together. Yes, the particles move closer together when the pressure of a gas is increased, right? Because increasing the pressure means you are compressing them, right? You're compressing them so that they are coming closer to each other. Third is the pressure of a gas at constant volume. So we are here we are keeping the volume constant, decreases, so the pressure is decreasing as the temperature increases, right? So we are keeping the volume constant, and we're increasing the temperature. So if you have a closed chamber and you're increasing the temperature, the gas molecules will, the pressure should actually go up, right? Why? Because you are increasing their average kinetic energy, and you're not giving them room to adjust themselves to keep the pressure constant, because you are not changing the volume of the container. That is fixed, right? Because we have constant volume right here. So temperature and pressure are directly proportional whenever the case is the constant volume. So this is actually wrong, because the pressure should also go up with the temperature. So the correct option is only statement 1 and 2.